Right. So let me share slides. Okay. So basically, yesterday we have started with this new chapter. I mean, like introduction to industrial processes, and then yeah, let me enlarge the screen. And then we have like gone through several things, several aspects. I think what we have gone through is yeah, I mean, we have looked on different things on the aspect of industrial chemical process, the definition of chemical processes, and what is actually things that you need to consider in the chemical processes, classification of chemicals, and yeah, the difference between bulk chemicals and fine chemicals, right? So we are going to continue with batch processes and continuous processes, but before that, if you notice over here, I think I forgot to tell you guys, I mean, we have one picture on your right, bottom right, okay, that shows a different helmet color. So those who will work in industries in the future, this is a basic knowledge for you guys lah. Okay, so we have different colors for safety helmets. Normally for white helmet, it is uh, for professionals, like engineers, managers, supervisor, or foremen. Sometimes foremen use white. Foremen sometimes they use blue. Foremen or superintendent. So blue is actually for technical operators, electrician, carpenters, and then red is for firefighters. But red normally you will see it if let's say there's a sudden call because of like fire or whatsoever, then uh, they will wear this cap. Otherwise, they just wear, I think maybe a normal cap, yellow or uh, yellow or white cap. And then we also have green. Green is actually safety officer. This is also worn during the fire drill or whatsoever. Gray color is for site visitors, but sometimes visitors they will be equipped or they will be given white color helmet. Yellow is things that you can see all around you. I think yellow is actually for operators, for operators. And then brown is actually for welders or someone who actually works with high temperature. Okay, but the most common one that you will see is white, blue, and yellow. I think the rest is for special case. Like for example, this one, he is actually the uh, technical operators. He's doing the process control over here. The process is actually controlled by a computer. And then you have an operator. Maybe they are discussing about problems or they want to see what will be the flows, the process, and everything. And this is actually for engineers, for supervisors. Maybe they will go to the site and looking at for inspection and whatsoever. Okay. So for me myself, you can see I'm wearing white helmet lah. So I'm not the operator lah. Saya bukan kuli lah. Okay. Alright. Okay. So yesterday we have seen the difference between bulk chemicals and fine chemicals. Remember, for bulk chemicals are chemical that is produced in the high volume with a less purity, but with a lower cost. Okay. And therefore, fine chemicals are chemicals that are produced in a smaller scale with having a high purity, but at the same time, the cost is also very high. Okay, right. So the differences, I guess, maybe you guys need to like memorize. Okay, and today we are going to look on a system model for chemical processes. Okay, So of course, in chemical processing, we have inputs, which is the raw materials or the reactant. Okay, and then you also have your mobile phase, which is the solvent. Okay, solvent is used to mobilize or as a solvent to dissolve the reactant and whatsoever. And then we also have like catalysts, okay, to accelerate the process. And then finally, we do also have energy like heating or for others, depending on the types of process that we are dealing with. Okay, so the output will be the products, and you also will have a byproducts or co-products. So the difference between byproducts and co-products, anyone knows what's the difference between byproduct and co-products? Siapa-siapa tahu? Anyone knows? Anyone can give a answer for that? What's the difference between uh, co-product and byproduct? Nak panggil nama ni. Muhammad Faris. Faris Khairi. Faris Khairi ada ke?
Ada, Doktor.
Ada. Okay, dapat dengar suara yang cute tu. Okay, alright. So, what's the difference between byproduct and co-product, in your opinion?
Saya rasa byproduct produk yang kita tak nak, tapi macam ni, produk tu kita tak nak lah, tapi dihasilkan co-product. Produk tu saya tak tahu, Doktor.
Okay, alright. Byproduct, okay. For example, kalau katalah, okay, if let's say we are doing fermentation, so fermentation from sugar, and then things that you will get, of course, sugar fermented, it will become alcohol, alcohol plus with CO2, for example. So CO2 is considered as byproduct, CO2 plus water, for example. So CO2 and H2O is considered as a byproduct. Product that is produced from the same process. Okay, so this, not to say that it is unwanted product, because byproduct sometimes can be used for other purpose. Like if you do fermentation and if it produce CO2, CO2 can be used for other things. Okay, water also can be used for other things. It can be recycled or whatsoever. Meanwhile, co-products is the product that we are looking at. Okay, but normally it produce in two, I think, like maybe like as isomers, okay, or it can be like what, when you do hydrolysis, for example, from polysaccharide, you do hydrolysis, it become different type of sugar, glucose, fructose, or whatsoever. But these things we still need it. You do fractionation, you do cracking of hydrocarbon, so like decane, you do cracking, it become pentane, it become whatsoever, hexane or whatsoever. This product is still I think produced from not from the one process, but it is actually as an effect of one process. As an effect, like cracking is more of like a physical or chemical treatment that from one product it becomes two. As I mentioned, byproduct is different. Byproduct meaning that from one product, one reactant, like for example, giving to you just now the example of sugar, glucose reacted with oxygen, and with the presence of bacteria, it become ethanol plus carbon dioxide plus with water. Okay, so carbon dioxide and water is actually the byproduct from fermentation process, because the aim is actually to get ethanol. Okay, meanwhile co-product is the product that you want. Okay, it is produced from one effect that, like I give you the example now, cracking of hydrocarbon. So you have decane, a very long chain. When you crack it, it become a fraction. So All these actually needed later on, right? Okay, just checking whether okay, so okay, and then we also have spent catalyst. Spent, what does it mean by spent? S-P-E-N-T. Spent is actually the, not to say the waste lah, but the used catalyst. Anything that is deal with the word spent or spent bleaching clay, SBC. If you work in palm oil industries, you will heard this bleaching clay, okay, that is used to bleach the crude palm oil, okay. The solvent, byproducts, waste, energy, and others. So chemical process operation are of the two basic types. So you have batch process, which operate according to the batch cycle, and then continuous process, which operate continuously under steady condition. Okay. So the difference between batch process and continuous process. So batch process, you can imagine that this process, it occurs on a cycle. Contoh paling senang, I think the simplest example, this related with your household chores, macam you basuh baju. If you put your clothes in a washing machine, so you know that this is a batch process. After it finish, you will remove out the wash clothes, and then you will like hang it somewhere, and then you put a new one. Okay. But continuous process, okay, is the process that the reactant is keep on added, okay, into the mixing tank. So for example, I think maybe if you want to produce soap, so if you want to produce soap, according to the recipe, probably you need to pump in the reactant continuously until it become soap. Then this can be considered as a continuous process. It's not a batch process. All right. So chemical processes consist of a number of sequential and integrated operation carried out in appropriate equipment. Example, chemical reaction carried out in the chemical reactor. Okay. So you know that for a chemical processes, it must be operated in the appropriate equipment. So of course, the use of reactor is common in any types of chemical processes. The precise operation sequence of operation and equipment specification depend on the nature of the process, operating condition, material use, and also product produced. So the equipments and the operation that normally you will see in chemical processes. If you want to do chemical reaction, what you need is a reactor. If you want to do distillation, of course, you will need distillation column. Okay, so those who didn't know what does it mean by distillation, distillation is more or less is a fractionation process. Okay, distill, like if you have a mixture between alcohol, you have methanol, you have ethanol, and many things inside. So you know that each and every chemical have its own special boiling temperature or vaporized temperature. Then you can actually use distillation to isolate the solvent individually. Filtration, you will need a filter units. Okay. But if you guys ask me, okay, doctor, what they will use in industry if they want to filter a product? Are they going to use a filter paper? You think that they will use a filter paper? What is your answer? Anyone knows? What is actually the filter units used if they want to do filtration in industry? Are they going to use filter paper? Siapa tahu? Anyone knows? Yep, Ki Yuan. Any suggestion?
Hello, doctor.
Yeah.
I think others than the filter paper, they also can use the filter membrane.
Okay, they is a good point. They can also use membrane, But membrane, you have to remember that it is a very porous, very fine porous material. So the process of filtration is very slow. It depends. If you want to filter water, maybe membrane is the best. But if you want to filter off solid materials, okay, then membrane is not a good material. So in industry, actually, they use solid minerals to filter solid particles. Like for example, sealite. Sealite. So sealite is actually calcite lah. It's like calcium carbonate material. Sometimes they also use silica powder. So what they do is they just pack this into a, a container or something like that, and then it will be function as a filtering unit. Okay, so this also will ensure that you can actually get a very, good filtration when you use a very porous minerals. Right, for drying, if you need to do drying, then you need a dryers. Okay, so dryer is like a heat blow, something like that. Okay, a fluid transport, of course, you will need pipes, you need valve, you need pumps. Okay, and process control. For process control, probably you need measurement devices, controllers, valve, PC, and whatsoever. I think what's lacking in our school is we don't have process control subject. I think if you go to chemical engineering, so they have also one subject on process control. They will learn about how to use PC or how to use software to control the chemical process. So they have like a simulation, one PC connected to a reactor. So you just play around with the computer, like you set the pump, you set the flow rate and whatsoever, it will automatically done. So probably this what we are lacking, in our school. If you need to do evaporation, then you need evaporators. Of course, it's more or less like a oven. You need to do centrifugation, then you need centrifuge. If you need to do like heat transfer, then you need heat exchanger. Granulation, then you need granulator. So granulation is more like a blender, like a crusher, pulverize or something like that. Okay, so this is one of the reactor type that I guess maybe you need to memorize. Okay, so in this subject, we are going to learn only two types of reactor, which is a batch reactor and continuous stirred tank reactor. Okay, so the first one for batch reactor, this process is considered as sequential. It is not continuous. Sequential means it occurs in the sequence. Okay, I give you the simplest example that you can imagine is when you wash your clothes using a washing machine. This actually considered as batch reactor. You put water, you charge it with water first, you put detergent, you put your dirty clothes, and then you start the washing process. After it finished, you just discard the water and it's finished. Okay, so similar thing in industry, if they do batch reactor, like for example this one, I think the picture that I've shown to you here is how they treat sludge water. Okay, water from sludge daripada your septic tank or whatsoever. Ini air kumbahan lah. Okay, what they did is they cannot do continuous process, because if they do continuous process, then I think sampai kiamat pun takkan habis lah, the treatment. So what they did is they just charge it first. Okay, they're filling the mixing tank, okay, with the material, and then after that they will do aeration, setting, and then they will do extraction, and after that they will discard the product. So over here, as I told you, they are treating the septic water. So they put some chemicals after mixing, after settling. Okay, all the solid residues will settle down, and then the pure or treated water will be on top. So they just remove out the water, and it will be later on cycle as your drinking water. Okay, all right. So the definition of batch reactor are defined as reactor in which no flow of mass across the reactor boundaries once the reactant have been charged. It means that once you have charged the reactant, okay, so there's no way that the reactant will be flow in at the same time. Okay, so no flow of mass. Okay. All right, so this is a mode of operation. Of course, the first one is you clean the reactor, and then after that you load it with the reactant. Okay, so adding the chemicals or initiators at time 0, and then you start the mixing. So after the mixing process or the synthesis or whatsoever process have stopped, then it will be considered as time final, and you will remove out the products, and after that you will unload the reactor for the next cycle. So the characteristic of batch reactor is also important for you guys to know. Okay. Right. So whenever I say it's important, so you just bear in mind that, okay, this is important. I need to take note on this. So the characteristic of batch reactor, of course, first one, each batch is closed system. It is a closed system. So once you charge it, we consider it closed. It is not open. It is not continuous. Okay. The total mass of each batch is fixed. Okay. It doesn't mean that, okay, you don't know what's the amount and whatsoever. Okay, because this is a batch process. The volume of density of each batch may vary as reaction proceed. The energy of each batch may vary as reaction proceeds. Heat exchanger may be provided to control the temperature. The reaction times for element, okay, of the reactive fluid is the same, and then the operation of the reactor is inherently unsteady state, okay, which the batch composition changes with the respect of time. At any time, the batch is uniform in composition, temperature because the efficient and vigorous stirring. Right. So far, any question for batch reactor before we move on to continuous stirred tank reactor? Ada soalan? Anything that you didn't understand about batch reactor? All right. So for batch reactor, this is actually the diagram. Okay. You'll see that in the continuous stirred tank reactor, CSTR. I think in most company or in industry, they call it CSTR. If you say continuous stirred tank, sometimes maybe they also don't know. But when you say CSTR, they know, oh, okay, CSTR. Okay. So sometimes also for batch reactor, they don't call it batch reactor. They call it BSR, batch sequential reactor. Okay. So for continuous stirred tank reactor, you can see over there that they have agitator, which is the stirrer. Any reactor normally have a stirrer, but over here you will see that there's a pipe or there's a inlet that shows the reactor 1 and reactor 2 valve that can actually charge the reactant continuously. And they also have flood level. Flood level means that if you have fixed the reaction at certain volumes, you cannot exceed this volume. If you exceed, then maybe you need to flush it off a bit. Okay, so that is why you need a flow level. And then there's also another things like a coolant, heater. Okay, so coolant is actually important in order to give the heat transfer or to maintain the heat transfer process. Okay, the definition of continuous stirred tank reactor are defined to be flow reactor characterized by intense mixing so that the properties anywhere inside the reactor are exactly the same as that of the exist stream. And sometimes in continuous stirred tank reactor, they also put some probes, like if they want to measure like conductivity, okay, they want to measure the pH, they want to measure the temperature, they have the temperature gauge and whatsoever. So it will be put together as a component, accessories. But you might wonder, like, I think those who are taking KIT 355, unit operation practical, maybe the practical under me, you will understand why actually you need conductivity meter in a reactor. The reason why is actually we want to see the percentage of conversion, how much percent yield have been produced. So if you do experiment in lab, okay, when you use apparatus, glass apparatus, you can see the product and whatsoever. But imagine if you are in industry, so how can you tell that the process have achieved 100% conversion and whatsoever? Because the reactor everything is made from steel. It's not transparent. You cannot see inside. Okay. So the other clue is actually when you use conductivity meter, you can measure. For example, if you want to produce soap, if you have more reactant, then you know that the conductivity value will be high because the free ion is still there. But if it has been paired and it has already formed a product, then you have no more free ions, then the conductivity value will be low. So this is actually theoretically how they can use this kind of logic in order to determine the percent of conversion. The characteristic of CSTR is also important. The flow through the vessels, both input and out streams is continuous but necessary at a constant rate. The system mass inside each vessel is not necessarily fixed. The volume or density of each batch may vary as reaction proceeds. The energy of each batch may vary as reaction proceeds. Heat exchanger may be provided to control temperature, and the reaction or the residence time for elements of the reactive fluid is the same. Next, the operation of reactor may be steady state or unsteady state. I think just now for batch reactor, it is unsteady state. Okay, but for CSTR, it can be either steady or unsteady. The fluid properties are uniform in composition, temperature anywhere in the vessels because of the efficient and rigorous stirring. Right. So I guess maybe I would like you guys to do a bit of homework later on. Okay. I will post it in one event in e-learning to do a differentiation between BSR and CSTR, batch sequential reactor and also continuous third time reactor. Maybe you can dig in some other informations apart from what you have seen in your lecture notes, and probably to differentiate maybe in terms of the features, how the reactor design look like, and then you need to send it to the e-learning. So I think I will give time for this at least by Friday lah kot. Okay. So this is considered as a homework lah. Okay. Any questions so far for CSTR? Anything yang tak faham? Anything you want to ask? Oh, okay. No. Thank you very much. Right. So we are going to continue. The multi-purpose or the product plan for bulk chemicals. So this actually, if you want to produce bulk chemicals, there's a few things that you will need in your industry. Batch reactor. Sometimes batch reactor is made from stainless steel. Sometimes it's made from alloy, more corrosion resistive metals, carbon steel and whatsoever. Agitator is also needed in the batch reactor. It's for the mixing. Glass line. Okay, if the process is not at a high temperature or not too corrosive, then maybe you can use glass line. Reflux condenser and also jacket. Jacket doesn't mean that the reactor wear jacket lah, pakai leather jacket or what. Jacketed is actually means that there's a lining, water lining outside the reactor. It is actually for the water or steam or whatsoever to heat up the reactor. So I think in industry, for your information, if you want to do heating, okay, we are not going to use Bunsen burner. We are not going to use heating mantle whatsoever, because the temperature required in a process sometimes it can be too extreme. Then these two things, like you use a burner or what, will not going to be useful. And of course, it is actually expensive if you use like electricity for the heating mantle, or if you use burner, maybe it's dangerous because you have an open burning. But in industry normally they use steam. Steam jangan duk fikir benda lain pula. So steam, okay, is actually a water vapor. So they have, I mean, in a plant that use water as a source, and then they will heat up this water and it become water vapor. So steams can sometimes can be categorized as low steam, medium steam, or high steam. So they have different temperature range. And then if, like for example, you need a very high temperature, then they will use high steam. So that is why in every industry they will have steam line. Dia ada macam satu pipeline steam. Okay. So I remember there's one accident a long time before that and there's a leakage of steam. I mean, like that operator actually want to open a valve, steam valve, and then the steam is actually sprayed at his feet. So you know what happened? Dia melecur lah. I think melecur teruk. He suffers burning, a very bad burning. And then I think because steam actually, boiling water is 100 degrees C, but steam sometimes it can be up to that. I mean, 200, 300 sometimes, very, very hot. So you can imagine how much he suffer. Okay. So materials feed system to the reactor, sometimes pump or whatsoever is considered as the feed system. Separation and purification equipment, if you produce like drug or anything that forms crystal, okay, then you need purification equipment, filtration, centrifugation, dryers, distillation unit, and etc. Material storage, okay, how to store the materials, and then process support services, utility, including heat transfer fluid, waste treatment, and also emission control. So if there's any gas that is formed, okay, you will see that in some industry they will use flare. Anyone knows what is the function of flare? Pernah pergi tak industry? You will see, or you just cross through a industry, you see like there's a like flare, atau dia macam ada obor, bukan obor kan, macam ada api lah dekat atas tu. Anyone knows what is actually the function of flare? If you call this as flare lah, flare, F-L-A-R-E, flare. Anyone knows what's the function of this flare? Siapa tahu? Saya duduk senyap-senyap ni, saya pun nak kena tanya soalan lah. Anis Sofia. Anis Sofia, ada Anis Sofia? Anis Sofia. Ada. Okay, what is the function of flare?
Flare, setahu saya, dia dekat kilang tu dia macam nak buang waste gas yang tu, yang tu lah.
Okay, so how about Wong Yili. Wong Yili, are you around?
Yes, doctor.
Right. I free to talk now? Not
Yeah,
really.
yes.
What do you think the function of flare?
I think it's a result of the combustion of those oil.
Okay.
Yeah,
And?
no, yeah, that's all.
Okay. All right. So thank you to both of you. Actually, the function of flare is basically to convert gas, hazardous gas or extreme gas into something else. Like for example, if you produce methane or other things, like in the process, then you know that is hazardous and you don't know where to keep this gas. So what they will do in industry is just they light up or they burn this gas so that it can be converted into CO2. So that is why when there's many companies or industries doing this, then the problem is you will have a very high CO2 emission. Then that's creating issue greenhouse effect or whatsoever lah. Okay. In some companies, they will use filters or maybe like absorber. They install the absorber in the scrubber or in the exhaust. Okay, so the absorber will absorb the gas and then they will store the gas, or maybe they separate the useful gas like hydrogen, CO2 or nitrogen for other purpose. Okay, right. So why do we need separation and purification process in the production of chemical? Of course, the answer is to ensure the purity of the produced chemicals. Okay. A typical sequence of separation processes used in the production of bulk chemical is crystallization, okay, from the mother liquor, okay, and then filtration or certification and drying. Of course, the other things will be like related in the equipments, like for separation and purification, factors that can be considered. Okay, you have to look on the quantity of material to be separated, rate of separation required, feasibility, selectivity, economics factor, whether it's cheap or not, quality, equipment, and also mode of operation. So the process supports or utilities in industries or plant service. So of course, as I said, in industries, normally they will use steam. So you will need steam, okay? You also need cool water for cooling process, chill water also, okay, for cooling purpose also. Other heat transfer fluid like coolant, normally coolant, okay? Inert gases, okay? So inert gases like nitrogen, argon, and whatsoever, it is used normally to maintain or to make sure that there's no effect of oxidation or there's no way of combustion to happen. Then the reduction process or hydrogenation process can occur, something like that. Okay. Sometimes you also need compressed air. Okay. Electricity, demineralized water, and deionized water. So that's two different things. Demineralized water and deionized. What's the difference? Demineralized water is that the water that you use, it doesn't have minerals. So what kinds of mineral that we are talking about? It doesn't contain sodium, it doesn't contain potassium and whatsoever. Meanwhile, demineralized water, normally deionized water, it means that it doesn't contain ions like chloride ions, phosphate ion, carbonates ions, and whatsoever in the water. But both actually, how to prepare this material, this water is actually by passing through it into a filter it. Okay, so the typical filter that they use is a resin type filter that can filter off minerals, or if you use anionic or cationic filter, then it can remove out the ions. UP, not up water. Okay, this is actually means ultra purified water. UP, ultra purification water. So ultra purification water, normally they will use a membrane to remove out like any bacterial or any residues. Okay, so that it will be super pure. So that is why it is called as ultra filtration. Purification, ultra purification water. Distilled water is also needed, and the effluent treatment. Of course, this in the case of if you want to discharge your waste later on. For purified water, okay, of course, the normal, I think usage is they use city tap water, okay, menggunakan air daripada PBA or whatsoever. But of course, they need to use filtration aid, like for example, by using ultrafiltration UF, okay, with 0.22 micron, They also need to, install like activated carbon filter, organic trap, and whatsoever. This is actually to ensure that the water used later on during the process is pure. And then for the material storage, of course, in industry, you will also need to have a warehouse. This is where you store the reactant, you store the products, okay, intermediate, solvent, catalyst, and etc. I think just want to share with you lah. Maybe I guess my lecture pun a bit boring lah, mengantuk je dengar. I think I have one experience when I was working in KLK lah. And I have to work during night shift tau. It was way back during Chinese New Year. So I have to work shift lah. Saya kena kerja shift malam. And then, our plant is actually very near to the warehouse. So I don't know lah, but maybe the Chinese colleagues or Chinese student over here can comment lah. I don't know. If you notice, in any industry, dia ada tokong kecil tau. Dia ada macam satu tempat semayang kecil, tokong kecil. You'll be surprised that at every industry you will notice this. So of course, for the prayers reason we understand. But my friend told me that in some specific place there's a guardian or there's macam ada kita kata someone lah who take care of the place or dia tuan kepada tempat tersebut. And then what happened? There's a lot of mystic stories related with our warehouse. So masa time tu saya kena kerja shift malam, and I remember at that time my technician cannot join me because he have emergency leave, family matters. So saya kena kerja satu orang. So what happened is I think when we are doing inspection, masa saya pergi dekat plant and just checking out things, suddenly I see people, someone running though. I just surprised lah, someone running. And then after that, when I try to like maybe search for that person, maybe guard ke ataupun operators, but it was midnight. I don't think that operators are outside there. Normally superintendent or technician lah, that will go occasionally just to check whether there's a leakage or there's other thing. But I don't think that they run lah. Like normally they just walk or what. So cannot find that person. But and then what happened is masa saya, I went back to my office and suddenly I saw that my office light is switched on. So I don't know. Like someone they switch it on. So this actually, of course, a very questionable story lah. Until now, I also don't know who switched on the light. I also asked my colleagues, is there anyone who switched on? I asked the guard also, he don't know. And yeah, but there's many story lah. If you go anywhere in the industry, if you check on their warehouse or whatsoever, dia akan cakap, warehouse ni macam scary sikit, apa. Okay, just to ni lah. To wake you up lah. Dengan cerita hantu selalu cedik sikit. Alright. Okay, so we continue a bit before we call for the day. It is actually on Flowsheets. Okay. So Flowsheets is actually like a map or like a diagram that shows the overall process. So whenever you want to troubleshoot a problem, so Flowsheet is a very useful guidelines to check which part that actually causing the problem. Okay, so in the Flowsheets, actually it is used to describe the operating details of chemical processes. There are numbers of basic types. So we have flowcharts. Okay, normally flowchart ni in block and also arrow charts. Okay. And we also have process flow sheets, okay, sometimes called as process flow diagram, as what you've seen over here. This is actually known as the figure in front of you, actually showing you the process flow diagram. And we also have this one, piping and instrumentation diagram, PID. Okay, so the difference is actually for PID, they actually didn't draw lah. I mean, like for process flow diagram, you will see, okay, there are the symbols, like pump, there are the symbols reactor, there are the symbols compressor, there are the symbols what heat exchanger, condenser, and whatsoever. But for PID is actually different lah. For flow sheets, it is actually a schematic representation. Arrangement and equipment, it's also interconnected with each other. It shows also the movement of material from one step to another step. It also shows the stream connection and stream flows and quantity, composition, operating condition, and etc. So that is why sometimes you will see in flow sheets, it can be too detailed. It shows the condition and whatsoever. So for this one, I think you guys need to slightly memorize. Nak memorize semua, I think it's almost impossible. But just look at the common one. Like for example, if you see like this one, like ribbon structure, you know that this is valve. Okay, and you see over here that it has like arrow pointing inside and arrow pointing outside. This is actually meaning that you have heat exchanger. So heat exchanger can be heater if the arrow is going inside, and condenser if the arrow goes outside. So it means that the energy is absorbed and another one is energy is released, something like that. Okay. Apart from that, pump. I think pump is quite common. It's very easy to identify. This is actually pump. Okay. Vessels like tank. Compressor dia bentuk pelik sikit, dia macam bentuk this one. This is actually compressor. Dia bentuk macam trapezium, something like that. This one is compressor. You have also this one, distiller. Kalau you nampak macam gini is heater or distiller. Okay. Number 10 is actually column. So column normally have like this one with like X, sometimes X. This is actually boiler, number 8. This one, boiler. So boiler is to heat. So that's why you see like water goes in, water goes out. This is a boiler. Okay. Heat exchanger, and then yeah, you have air cool condenser. So this, I think common symbols need to be memorized lah a bit for your information. Another example of a common symbols which you can look in the slides. Okay. Yang lain-lain tu, I guess, like centrifugation and pump, mixer, fan, agitator, propeller. This one is propeller. It's different with valve. Propeller dia bentuk macam gini, dia ada tangkai, macam kipas. Valve is different. Valve is like ribbon size, and then you have like this one. Venturi, the symbol is like this. Yang ni saya tak payah beritahu lah. I think this one my son also know. This tank, truck, trailer ke apa. Okay. Alright. So these are the examples of flow charts. A simple flow chart can be used to show the main process routes through the process and to depict the main operation. Okay, so like for example, this one you see that the mass of the raw material is around 3 kilos per hour being inserted, and then they use ore, and then dirt is also put over here. Okay, and you'll see the process flow after washing goes to the settler, and then after that purify, and the water can be recycled again, and then after washing also you can discharge the ore, and then it can be later on dry to remove out water, and finally you will get the pure ore. Okay. Another thing is process flow sheets again. This how to see the difference. I think just now is the flow chart. In this flow sheets, you'll see this for process. They put the heater, okay, reactor, heat exchanger like this one, condenser, boiler, pump, compressor, and whatsoever. Okay, This one is pneumatic valve, PC, pneumatic valve. Dia ribbon, lepas tu dia ada payung pula kat atas. This pneumatic. Alright, meanwhile for PID, it actually shows the equipment details, arrangement, name, dimension, rate of capacity, occupation time, temperature, pressure, and other details like pipe, valve, fittings, pumps, instrumental control loops, service, and also layout. Okay, so this is actually the examples of PID. So as I said, it's different with Flowsheets, process flowsheet, because process flowsheet is actually showing the true symbol lah. Meanwhile, for this one, it's just showing the reactor, and then you have a heat exchanger. Okay, a valve over here. It's very simple, but yet a bit complicated to understand. Okay, so this is actually a process. I show the examples, pressure swing distillation of acetone methanol. So you have a feed of a mixture between acetone and methanol. So you have like one column, okay, that actually separates methanol, and another column that separates acetone. Okay, right. So for more information about process flow diagram, so please go to this link. Go and watch the YouTube. I think the use of YouTube, maybe jangan you misuse the ni lah. I mean, tengok pula cerita Korea pula kat dalam tu, ke cerita benda lain lah, Didi and Friend ke apa ke. So just watch it for educational purpose, is okay. Alright. So this last few slides before we end the lecture. Examples: construct a process flow sheets of a batch esterification process from information given. So you have a high purity of FFA, free fatty acid, added into the reactor together with methanol and co-solvent. So you know when you have fatty acids with methanol, then the process of trans-esterification can occur. Okay? It will produce biodiesel. So the product mentioned over there is biodiesel and glycerin are separated during the refining process. The unreacted methanol and co-solvent can be recycled. So if the information is given over here, so you can actually imagine what will be the inlet, what will be the process, what will be the outlet, what will be the recycle things and others. So this is actually the drawings. You have a high percent of FFA, charged together with methanol and co-solvent. It goes into the reactor, and then after that it goes into the refining process where you will actually produce the products, okay, that later on separated as biodiesel and glycerin, and the co-solvent and methanol mixture will goes into separation and recycle into the reactor again. Last one that you can actually combine in your homework is this one. Please produce a process flow diagram, okay, of production of aspirin. Write the chemical reaction for the production of aspirin, okay, acetyl salicylic acid from salicylic acid and acetate anhydride, where phosphoric acid is used as a catalyst, and then after that construct the process flow sheets for a batch process to produce aspirin in industrial scale. So this actually I want you to do as a homework as well. So you can combine with the homework that I told you to differentiate batch reactor and continuous stirred tank reactor. So please find out the information. I guess the synthesis of aspirin is very easy. You can search it online. But I give you a clue. It is made from salicylic acid and acetate anhydride, where phosphoric acid is used as catalyst. And what will be the consideration? The temperature, the time curve, pressure, whatsoever that you can get from process, and what will be the step that is needed, filtration curve, separation curve, whatsoever that you can construct. Okay, is it clear? All right, so I think we have done for chapter 1. Probably tomorrow we will start with a new chapter on industrial gases. So before that, is there any question that you want to ask? Anything? Ada apa-apa soalan? Anything? Ada soalan? Ada? Tak ada? Right. So if there's no question, I believe I think maybe we can adjourn the class. So please fill in the attendance. I mean, using the Google form, the same Google forms. Okay. I still need the response what you have learned today, so that you can catch up with the course. And I guess thank you very much for Wow, dengar suara. Yeah. Who is this? Poilinko. Anything you want to ask?
No, doctor.
You just suddenly unmute yourself. Okay. All right. Okay. So if there's no question, then probably I will adjourn the class. Thank you very much for your kind attention, and hopefully to see you tomorrow morning 8 a.m. Thank you very much. See you guys. Goodbye.